A very warm welcome to our lecturer, Madam Mageswari. Today, we'll be explaining about our data structure project. Come, let's go. So, before I start, I would like to introduce my team members. So, first of all, we can see Darwin Danraj, Jason Raj, myself, Harish Krishna Reddy, and my another team member, Kishan Rao. Okay, so our data structure program is a C++. We're going to do binary search tree. Okay, binary search tree is a node-based tree data structure which has the following properties. The first one, the left subtree of a node contains only nodes with key lesser than the node's key, where the right subtree of a node contains only nodes with keys greater than the node's key. The left and right subtree each must also be a binary search tree. Okay, so I'll be going to the question. Write a C++ program to show implementation of binary search tree BST using linked list. Now I would like to pass to my team member Darwin Danraj.
Okay, thank you Harish Krishna Reddy. Okay, let's see what is binary search tree. According to Harish said it properties, yeah, it's true. So basically we are seeing that 7 is the root of the binary search tree that we have chosen, and yeah, left it goes for 4, which is lesser than, and 6 below it, and it is on the right because it is more than 4 but lesser than 7. It is the reason why it is located at there. And the following, we can see 3 is below it because it is lesser than 4 and 7 as well. And it is going below it. So you can see 5 at there. And below it, there is 2 as well. Okay, at the right side of the binary search tree, you can see 8. Why there is 8? Because it is more than 8. Okay, example we have done through this, and we have entered the value of 7, and the enter value of node was 8, and it's saying that it is on located on right, and enter value of 4, value entered is on the left, and 6, so the value located on the right, and for the 3, value entered is on the left, and for 5, the value entered is on the left. So enter value of node is 2 and it is on the left. So it is display on in order as well at the end. So it is how it works, but we have done the coding. So let's see. Showing through an output itself for the result is not going to be sufficient. So let me explain more about it. How did it works and so on. Okay, we have done the code in not pre-set up numbers in it, so that the user can enter any of the things that he wish on it. Okay, let's see. Okay, so let's go through it. So firstly, we can able to see under void create, right? There is a value of I in it. So the value of I, we have before it while. So it has to be doing loop on it. So I equals to less than 7. So we have decided the number is 7. So if you want to reduce any numbers, you can just do it by changing the number. So let us change it to 3 right now. Okay, enter 3. Okay. Okay, thanks for it, Kishan. So let's go through it. Okay, first thing is on the linked list. Binary search tree using linked list was the title given, and yeah, we have to use linked list for doing a binary search tree. So we should have a data and link beside it in linked list. Basically, we have learned it, and yeah, if you see the root equal to null null, and root we are creating it as a new tree. So the user have to enter value for root node, okay, and it will be stored at root data. So the linked list name is root, and it will be stored on the data, and the size would be null. the link would be null. So basically it would proceed to next. And yeah, now we are changing it to binary search tree equal to root, because in a binary search tree, there should be only one root. So we are proceeding it to changing the root to binary search tree, which is BST in this variable. And we have choose to enter the value of node in it, and it will be stored as value. So it would proceed to next while true. So if value is less than the value we have entered before, right? So before value, such like we have entered 7 for first thing, and after it we are entering a value less, so like 6, let's say. So it would be on 6. 6 is the value, so it would be proceeding to below 8, and it would store it, and it would be on value entered is left if it is less than. And if it is less than, it is stored as K, as you can see. If not, it would be proceed to next. You can see else value, a minute, okay, else if value more than BST data. So BST data is previous data that the number we have entered, it would be stored. So it would be comparing. Apparently, to took a decision for next, we have to compare with it with the previous data. So the linked list is the most important, so that it can store the data and link as well. So it would proceed to next. So if the value is more than BST data, it would be known as BSTD. Previously, if less, it was BSTK. So now it is BSTD, and it is null. So it would be forming a new tree at that. So it will be comparing. If it is more than BST data, it would say, the system would say that value entered is right. So it would be doing this based on it. And if you see, the linked list would have data and link in it. So we have state that everything is null for the link. Let's say if the link is not null for BSTD, it would break, and it would go to in order. So in order, it basically the coding of to arrange it in order. And for integer main, so we have put it display in order, and after display the in order, thank you. So let's try to run this out. So Kishan, execute it. So we have done it with the limitation of 3 numbers. We have adjusted. So let's say, let's put the value of root is 7. 7 again. Okay, the value of node is 2. Okay, the next value, let's go more than 7. So let's try 10 instead, 2 digit. So the value entered is on the right because it's more than 7, and the value is less than 7, so it goes to the left. As you can see, it's clearly a binary search tree. We have completed it with linked list as well. So the display in order was 2, 7, 10. So it is the end output, and we have created binary search tree as well. We have insert item, which is insert every node, and we have display item in order as well, as you can see in binary search tree. And I hope you all understand my explanation, and I hope it was clear. And yeah, now proceed to Harish.
Thank you, Darwin. Thank you. It was very interesting. And so now I would like to continue. So, so come, let's explore more about C++ program. Okay, so our second question is write a C++ program to show the sorting methods based on input by user. So in this case, our team have chose 2 sorting methods, which is selection and which is bubble. Okay, first, Selection. The sorting method is based on in-place comparison and divides the list into two parts. The sorted part on the list end and the unsorted part on the right. Whereas bubble, a straightforward sorting method that iterates across the list, comparing neighboring components and swapping them if they are out of order. So now I would like to pass for selection. I would like to tell to Kishan, and for bubble is Jason Raj. So now let's go to Kishan.
So, thank you. So, as for selection, the selection sort algorithm sort an array by continually choosing the smallest member from the unsorted segment and placing it at the beginning. In a given array, the algorithm keeps two sub-array, the sub-array which is already sorted, remaining sub-array which is unsorted. Okay. So this is a general explanation on the selection. Okay. And if I go for an example, okay, so let's use 2, 1, 8, 4, 9, 6. Okay, these are the numbers that that we have chosen. Okay, first it will have one of it will one is from selecting, another one more we will go choose. We the selection tool, it has to fix and keep which is the smallest member. So 2 will be compared with 1, and when it's compared with 1, 1 is smaller than 2, but just to be aware, it will go and check on 8, 4, 9, and 6. And as the final 1 is the smallest, and it will go to the first place. And next, they will swap to each other. 1 will go on the first, and second, 2 will come to the second place. And and also again, since 1 is done, we will go with 2 and compare with all others. So 2 will be compared with 8, 4, 9, and 6. Since 2 is the smallest, and you will go to the next. Okay, once it's already fixed there, you will go to 8. Okay, after 8 will be compared with 8, 4, 9, and 6. Okay, with the next one. But when 8 is bigger and 4 is smaller, it will swap with this. But before that, they will also check with all the other placement. So it will change to 4. So 8 will go to the next place here. So next will be 8, 9, and 6. So once they check with 8, 9, and 6, 6 is smaller than 8. So 6 will come next. And as normal, 8 and 9 will come on next. Okay, so let's explore more on the program. Okay, so let me open on selection to selection that we have done. Okay, from here I want to explain a little. That would be we have as previously Darwin has said, we have our initial temp D. D is equal to V based on all the initials that we have put in the whole coding. From here, I would say this is the array for to make an array to save and whatever that we are doing. So that's why we have array. And the main part of here is void selection sort. Okay. So as you all can see, in the initial is I, J, and I minimum. Okay. So I is equivalent to 0. If I is smaller than the size minus 1, so it means that when it's smaller than the previous one, it comes to the exact portion, and it will bring to an exact algorithm. So that's why we have that size is -1. And before that, for other than that, j is equivalent to I plus 1. And this is all is because of the size, as I showed you all previously. How does it change on based on the placement, based on the size, what's the number where it should be placed. So it also checked in all
before it's confirmed with one of the numbers, it will confirm with all the other numbers that is in the initial in the set, and then it will go. And I minimum, when we have that already the maximum number that it already checked everything, and the last number, and there's nothing to compare with, it will break. That's why it is swap. That's what we are showing here. It will break and we will get the final output. So in here we will enter the number of elements as we can see, and we will also get before implementation sorting out, and also after implementing sorting sort. So it will also, we will show before and after. We will get both, and finally we will show thank you. Let's run this and check if what I'm saying is we have it or not. So let's run. Okay. For this, can I ask Harish to give me some numbers?
What kind of number do you want me to do? Anything?
Yeah, any numbers.
2,
Okay.
1, okay.
2, 1,
8.
8. Okay.
Sorry guys,
So
I think you just entered two elements there.
yeah, two elements. So we are using the two elements, and the entered number is two numbers, 1 and 8. So the element is based on the number of elements that we have put. So if 2 only, it accepts the number of elements accept is only 2. So 1 and 2. So I mean 1 and 8. So as who Harish has given us a random number. So let's go once again. So run again. So, and number of elements, let me give about 6, let's say. And now, Harish, can you give me a sample of numbers now?
4,
4,
7,
7,
9.
9. We need 6 numbers.
Why don't you try less than 4?
Less than 4, alright. 2
2,
or 3. 1
3,
more.
and maybe I'll just put 1.
Okay.
So as you all can see, before implementing sorting, sort is 4, 9, 4, 7, 9, 2, 3, and 1. But as I showed you all previously also, it will be sorted based when it checks. We cannot see what is going on between, but it shows us clearly how does it run. So
Yes.
we will get 1, 2, 3, 4, 7, and 9. As I said, it will check all the way through if is there anything that is smaller than 4, and when it goes to 2, it feels that 2 is smaller than 4, 3 is also smaller than 4, but the smallest would be 1, so it also falls into the first place, and the next follows by how it has to go. So I think I have given you an clear explanation on this. Now let's I'll pass it back to Harish.
Thank you, Kishan. Thank you. It was very thing. Let's pass to Jason now to talk about bubble.
Thank you, Harish. Okay, let's see what is bubble. Bubble is the simplest slotting algorithm, which is called bubble slot, which operates by periodically exchanging nearby components if they are wrong order. This algorithm is not only suitable for large data sets, as its average and worst case complexity are of O(n)2, which the n is number of items. Next. Okay, let's see this example. So, okay, now there's a set of numbers, on the first row. So 218496. It's a set of numbers. So when when it comes to bubble will compare first two numbers. As you can see, I have highlight 2 and 1. So for 2 and 1, it will start to compare. Then once it compare, it will choose the lowest number to swipe first, to swipe in front. So 1 will come in front and 2 will be back.
Sorry, Jason, to interrupt. So, do you mean that it would compare side by side only?
Yes, correct, Darwin.
Okay, thanks for that.
That's how the bubble works. Actually, it compares side by side. So first it will take the first two elements. So for example, 2 and 1. So it will compare 2 and 1. So it will choose the smallest number, and the smallest number will swipe in front. So as you can see on the second row, 1 have come in front and 2 have been behind. But it's not going to end. It will continue to the next set of numbers, which is 8 and 4 on the first set. So it will compare side by side 8 and 4. So 8 and
Above
4,
one, Kishan.
the
Above.
first one,
The above row.
the first row, Kishan.
The pink one, pink box. Yeah, compare it.
Yeah. So 8 and 4, it will compare side by side, and it will take the lowest number and it will be swiped in front. So 4 will come in front and 8 will be on the behind. And the program will still go on, and it will check for the next set of numbers 9 and 6. 9 and 6 will be compared, and it will choose the lowest number to come in front. So 6 will come in front and 9 will be back. So once the set once the it runs for the first set of numbers, it will continue back. If it will continue to swipe, because there is still the number of orders haven't reached the lowest to highest. So on the second set, as you can see, 1 2 4 8 6 9. So uh, it will compare the first set, second set, and third set. As you can see, 8 and 6 is not in order, so it will be compared. And once it compared side by side 8 and 6, 6 will be swept in front. So 6 will come front and 8 will be behind. As a result, you can see on the last row 1 2 4 6 8 and 9. So that's how a bubble works.
So,
So,
this is
Jason,
how basically computer does no ascending order, like humans, right?
Yes, that's how the algorithmic works in bubble.
so
So
Jason, see, side by side will be going through until it gets a perfect order, right? The side
yes,
by
it
side.
it will compare side by side, and it will start to swipe front and back
So it
until
doesn't
it,
mind how many time, but it will make sure that it comes in order.
yes, it will be like loop. It will loop, and until when it's reached to the end, where the lowest to highest, it will stop, and it will stop. It means the swiping will be stopped. So as you have asked those questions, let's explore more on the C++ programming. Okay, so this will be the C++ programming for bubble slotting. Okay, on the first white swiping, uh, where okay for the first white swiping. So first we have to declare the temp for integer. Then temp equals to d. Actually, temp the full form of temp is temporary. So temporary equals to d. We will then d will be set as v. Then v will be set as temper.
It
If you
means
ask
that
why,
P and V are comparing side by side, right?
yeah,
Just like you said. Yeah.
that's why it will be like upper equals to D, then D equals to V, and V equals to temp. So because it be side by side, it's comparing side by side for first set, second set, and third set. So on the second line, white display. White display is for the displaying the array, because we are using the array for method for bubble inside the bubble. So we have to declare the array and with the size. So we have included the array with the size, and the third one, white bubble slot. So white bubble slot is the one for the for the slotting, for the swiping method. So it's comparing. So we have to declare that too. So we declare the array with the size, then with the loop. We have include the loop because it will loop back. So where we have included I equals to 0 and I is less than size. Then integer swipe equals to 0. Then integer j is equals to 0 and j is smaller than size minus I minus 1. If you ask why I minus 1, it's because we are minusing the numbers. As we going in front, it will minus the flow.
So it's less number beside, so it will move front, so it minus 1.
Yes, Darwin. Yes,
Okay.
that's right. So then it will goes for the swiping until when it stops to swipe, the loop for loop will stop and it will break. So there's no more swiping, and the last format, the lowest to highest, will be formed.
So meaning that lowest to highest number, so no swapping at all at the end, so it would break the loop, right?
Yes, correct, Darwin. And last, int main. So the main function, we have to declare the main function, where the main function we will be asking for the enter the number of elements, then we will be getting the output before implementing bubble slot and after implementing bubble slot. So we have declared everything. Why not we run the program now? Kishan, can you run the program?
Yeah, sure.
Okay, so we now have to enter the number of elements. So why not we use the same number of elements, set of numbers as we use in the example. So enter the number of elements equals to 6.
Okay.
So enter number of elements 2,
2,
1,
1,
8,
8,
4,
4,
9,
9.
and 6. Okay, once we enter the number of element, we can see before implementing slot 218496, and after implementing the bubble slot, it shows 1, 2, 4, 6, 8, and 9. As you can see, it's same as what I have shown in the slide, the example. So it will the process where it will compare side by side, and it will start to swipe from until it reaches to smallest to highest. Once it reaches to smallest to highest, it will stop, it will break the loop, and program will end. So we will get the result. So this is how bubble slot working in C++ programming.
Okay. I think it's just the difference from what I explained and what you explained was they do side by side, but my one goes all the way through.
To back, it goes through the whole thing. So thank you, Jason. Thanks, Kishan, and thanks, Darwin. I feel that you guys really explained very well and very detailed. It was so perfect. So, guys, I think hope you guys could understand what my fellow team members explained to you all today. And if I wish that you guys could understand every detail they pinned out today. So I hope you guys understood. And do you have any questions, anything you would like to ask us? Please comment below. So I hope you all like this. And that's all from us. Thank you and see you all again.
Thank you, guys.
Thank you. Before that, don't forget to subscribe and follow us. Okay. See you all.
Like, share, subscribe, bell button. Tick, tick, tick.